Today's theory is called arrays for two-step experiments. Now, an array is just a table. It's another word for a table. And it says that it can be used to list the sample space of a two-step experiment. Now, sample space, remembering, is all our possibilities, is our sample space. So we can use a table to list all of the possible outcomes. When listing outcomes, it's important to be consistent with the order for each outcome. What it means by that is that this is two steps. So we're going to have a result of our first experiment and then a result of our second one. We've got to make sure that when we list them, we have them in that order, first and then second. For example, in this example here, the outcome heads tails is different from the outcome tails heads because we got them on different tosses. So when two coins are tossed, the outcome of coin one is written first in each cell of the table. So what that means for us here, we can see, is that we have the first column goes in our rows, and our second toss, our second coin, goes in our columns. And that is because we are used to, in maths, it's very usual, not just in maths, but in everything, if you're talking about Excel, etc., is that we have our row first and then we have our column second. That is used in Excel, it's used in spreadsheets, it's very established. So we're going to put our first experiment in our rows and our second one in the columns. The sample space for tossing two coins, we can see all these results. Okay, so our probability is still given by the number of favourable outcomes, number of outcomes where the event occurs, divided by the total number of possible outcomes. So if here we were looking for what our probability is of rolling one head and one tail, we would look in the box and there are two. We could have a head and a tail, or a tail and a head, and there's four possible. So our probability would be a half. Now, some experiments are conducted without replacement. So what that means is that if we're talking about heads and tails, flipping a coin, there's no such thing as doing that without replacement, because every single time that we toss the coin, it has got both a head and a tail. But if we were doing an experiment by pulling coloured balls out of a bag, we might have 5 red ones and 5 blue ones in there to begin with. If we pull one out, there's 10 in there with 5 possibilities that we've got a red one, we've got 5 out of 10 chance of getting a red one. If we put the ball back, then we've still got 10 balls and we've still got the same probability when we go for our second trial. But we could leave the ball out of the bag. Then there would only be 9 balls in the bag. 4 of them would be red, 5 of them would be blue. The probability of getting a red the second time round would be the 4 balls left divided by the 9 total. So what we're looking at here this time is we're looking for experiments we're going to call with replacement and without replacement. With replacement, again, is when we have exactly the same elements for the second one as we do for the first one. If we are tossing a coin, it is always with replacement. Okay, so we have a look at our down here. What they've done is they've got the tables and it's shown our sample space. Here what they've done is they've got 2 letters are chosen from the word cat. So we put cat across in the row and cat also for the column. And here, just to prove it's wrong, what they decided to do is put them the other way around, with replacement and without. When we list, and they've decided to list the row for the column first before the row. So, thank you textbook for being completely inconsistent. What we've done here is they've put the row up here. The first thing they've done in the columns, the second thing they've done in the rows is probably still a good idea or a better idea. to do them so that you put your first one in the rows and your second one in the columns. But they have, if we have a look here, they have managed to list the columns first when they've made their lists. Anyway, what we've got here is if we're replacing, we put all the letters back, which means if we pull a C out first time, we can pull a C out the second time. If we pull out an A the first time, we can also pull it out the second time. And if we pull a T out the first time, we can also pull it out the second time. So we have all those possibilities. But if we look at without replacement, once we've pulled a C out, we can't pull another C out, so there isn't any. So it's impossible to have two C's. Similarly, it's also impossible, if we're not going to replace those letters in a bag, to pull out two A's and to pull out two T's. And so with replacement, we have a sample space of 9. Our probabilities are all going to be out of 9. Without replacement, because we didn't put back either the C when we got it out first time, or the A when we got it out first time, or the T when we got it out first time, there's only 6 possibilities, and we can't have two of the same thing. Okay, so let's have a look at chunk 1. So chunk 1, we're looking at using a table for multiple events. All these are going to have replacement. So a spinner with the numbers 1, 2 and 3 is spun. So we've got our spinner, thank you. We've put our spinner down here in the rows, and then the card at random is chosen from the letters A, T, H and S. So we have got them in our columns this time. So this is second and this is first in our orders. Now it's asked us to draw a table of this, the sample space of this experiment. This has been done for us here. And I guess what I'm going to do is I'm going to do them across to the left anyway. So we need a sample. Got to draw a table, and it's got to have three numbers, and then 3 and 4. Apologise for the ramblingness of this. Hopefully I'll get better at my verbal stuff. We're going to put 1, 2, 3 down the side. 1, 2, 3, and then across the top we've got our letters A, T, H, S. 1, 2, 3. And I'm going to continue. I think it just makes it clearer if I do my table and put my letters and numbers outside the table. Okay, so I've got, when I'm doing them, I've got a 1 and an A. So I'm simply writing down the row first and then the column second in all of these. So I've got 1T, 2T, 3T. I've got 1H, 2H, 3H. I have 1S, 2S, 3S. So there's my table. It's asked me to construct that. I've done that straight ahead. How many outcomes does this experiment have? Well, I've got 12. So that was B, 12. And it's asking me, find the probability of the combination 2S. So what I can see is my probability is going to be out of 12, because I've got 12 combinations. And 2S is only one 2S. 2S is over here. So it's a 1 on 12. And then it's asking me for, find the probability of an odd number being spun and the letter H being chosen. So I can have either, I've got an odd number. Now I can't get my mouse to work. What have I done? I think I'm no, I'm not. I'm after that. Okay. So what I've got here is I am after a odd number and the letter H. So I can have 1H or 3H. So 1H or 3H. That one is okay. This one is okay. 2 on 12 equals 1 on 6 is my probability. Alright, so now what you're asked to do is you're being asked to do these questions here. Let's have a look at what we've got. We've got a coin. Question 4, a coin is tossed twice. So you're going to construct yourself in your book, construct yourself something that looks like, well, that's what we've got. What we are going to do is let's do what we're meant to do, construct our table. Let's put our coins, our first one, heads, tails, our second one, head and tail, and then construct yourself, except that I'm in the wrong place. So I'm having an absolute shocker today. Let's go to this example, not next lesson's example. And chunk 1, a coin is flipped and then a regular die is rolled. Copy and complete this table to list the sample space for this experiment. Okay, so good. We have our coin in our rows, which was our first thing, flipping a coin, and then we were rolling a dice. It's our second one here. You're just filling them all in. Remember, put the row first and then the column second. You're filling that into that table. How many possible outcomes are there? You're going to count up how many you've got. Write that answer here is B. Find the probability of the pair H3. So look for how many H3s you've got. Put it into a fraction with the total number on the bottom and how many H3s you've got in that table on top. Find the probability of heads on the coin with an odd number on the die. Okay, so we're looking for H1, H3 or H5, I guess. You're finding the probability of that. All right, have a look at 6. So in 6, we're doing the same thing. A letter is chosen from the word line. So that was our first choice. And another is chosen from the word ride. So that was our second one. So again, they're doing the right thing. Putting the first one in the row, second one in the column. Who knows what they were doing with that example from the textbook. So now what you're going to do is just going to copy them all in. So remember, put the first one in and then the second letter. Do that for the rest of them. And then answer these questions. B, how many possible outcomes are there? C, find the possibility of N first and then R second. So it's written PNR. You're looking for the NR and then finding the probability for that. So furthering on from that, you find the probability of LD, L from the row, D from the column. Now you're after the probability that 2 vowels are chosen. So you've got a vowel in your first in line and you've got 2 vowels in ride. You're looking for the combinations where you have 2 vowels and you're going to be counting up how many there are and then putting it over the top as a total. Find the probability that 2 consonants are chosen. It's the same thing. You've had 2 vowels in line, you've got 2 vowels in ride. You've also got 2 consonants in line and 2 consonants in ride. So you need to find out when, for instance, you've got them lined up. So L and R is 2 consonants. And then the last one, find the probability that the 2 letters chosen are the same. So what we notice is that we do have 2 I's, an I in line and an I in ride, and we've got an E in both letters as well. So you're looking for the probability that the 2 letters chosen the same. Remember, you can have both those probabilities, I, and E. Okay, so you should be able to get through those. And then we have this next one you can do for homework. See if you can get someone to read that out for you, or simply you may be able to do this. This is our spinner 1, and spinner 1 has been written on there. This is our spinner 2, spinner 2's across here. So you're completing them, and then you're looking for, once you've completed your table, you're looking for spinner 1 being red and spinner 2 being blue in the first question. The probability that both spinners will display red, so 2 reds, 2 by red. Probability that one of the spinners displays red and the other blue, so probably 1 by red, 1 by blue. And the last one, probability that both spinners display the same colour, so you're looking for the same colour on each